Yo, so what's up, people? Take two. Planate Veritas. This is Robert Pisano. I got John. I got Marcus. We're getting another person coming in here. My boy Eric. We're gonna try this one more time. I had to use a little bit of physics, to fix my problem. So I'm in a cryogenic state right now with my system. So audio should be better. Again, we're talking about what is science, real ISS, and we're gonna do a little virtual physics experiment, wave cancellation. And we're going to talk about some other things with regard to double slit. Some people have been commenting on that. And I've had people send me emails on some video regarding how they may be faking things up at the ISS. And I'm going to let you guys judge for yourselves when we put it up. Marcus is here to interpret two German videos about a facility located in Cologne, Germany, called the Gasometer. And he's going to break it down for us. Okay? My boy Marcus Muller, I got John, Eric's going to come in, and today we're talking about what is science. Now that I got John in here, and he's late, he was late, so I'll forgive him on that one. He's going to do the presentation explaining what is science and what the process is, and then we'll move on from there, people. All right? So I'll be checking out the chat, maybe answer a little bit of questions, and John will be going for it on the presentation. Johnny boy, you go ahead, do your share screen, present to everybody. Hold on, let me see. Let me present you, Jay. Okay? To everybody. Yeah, you should be. All right, Jay. So you're presenting to everybody. Go for it, big man. It's all yours.
So you can, yeah, I can see it. I'm getting some feedback here. It's echoing pretty bad.
You shouldn't have any feedback now because I muted my mic. So if everybody else can mute while you do your thing, we'd be cool. We'd be good to go.
Okay. So we're good? Yeah, that sounds good, Robert. That sounds good. All right. So let's lift the veil here and see if, you know, what they're saying is science is actually science. So we'll start out from the word scientia, where it comes from, and it comes from science or scio, and it's basically to know or knowledge. So how can we know things empirically or objectively, whereby eliminating the subjective? You know, like consensus votes, the loudest voices, ruling parties, opinions, and things like that. Well, it's all in the method. And here it is, the scientific method. So I highlighted 3 of these to deal with them specifically. The other ones are more logistical in nature, not that they're not important. So science isn't an entity or a result. It's simply a method of inquiry. So science doesn't say, run, jump, point to, swim, do the hokey pokey or anything else. Science is about testing variables. If you don't get anything else from this, then remember that statement, because that's the most important statement right there. So the first one, observe a phenomenon. See, this is where most head off the rails, right with the first step. And it's somewhat confusing to most. It's not make an observation or ask a question or conjure a phenomenon. You have to observe a phenomenon. It's an action that you observe. It has to be based in reality so you can have the ability to test it. It's not just observe as in observe nouns. You have to observe a phenomenon, an action or a verb tense. And it has to be repeatable. It can't be a one-off event. If so, how could you test it? So from Niels Bohr, no phenomena is a phenomenon unless it's an observed phenomenon. So if you try and circumvent the scientific method and hypothesize observations of nouns or make an observation or merely ask a question, this is what you're reduced to every single time. Example, I observe a tree. So what's the hypothesis? I mean, how did this tree form? It's invalid. It's not observed. What circumstances led to this tree growing in my backyard? Invalid again. It's not observed. The tree formed by evolution. So that's invalid too. It's not observed. So and you got a begging the question fallacy in the hypothesis. Okay, what's the test? So post the formal scientific hypothesis and please elucidate the independent variable and what you're measuring or predicting. That's the dependent variable. So okay,
Whoa.
got
Well, let's go back to the tree.
okay.
Real quick.
Okay.
Let's go. I got to play devil's advocate on this. Okay, let's go back to the tree.
All right.
There's a tree in your backyard.
Yes, there is. There's two of them.
That's an observable phenomenon.
No, that's not a phenomenon. It's a noun.
Okay. So we observe a tree.
Yep.
All right. What's the hypothesis? You're talking about how the tree got there. We don't know. Okay. We can't test that.
Right.
All right. How did it grow? We can't test that. How did it get there? We can't test that because you can't. It's not. It can't be observed.
Right.
So would it be logical to say, how the hell do we know that it's even a tree?
Now, it's still a tree. You just can't
By what standard? By what standard is it a tree?
You can't cause and affect it. That's the whole deal with scientific hypotheses.
So the fact that I can't cause and affect it, we just have to collectively agree that's a tree.
Yeah, we all see that it's a tree, and there's a tree there.
Okay.
Okay.
And I guess the only way to prove that there's something actually there is, hey, go run for a pass towards that tree.
No, it depends on the question. See, a scientific hypothesis, its whole goal is to elucidate the cause of the effect. That's what a hypothesis is.
Yeah, but this goes back to what we talked about this past weekend. Cause and effect. If you can't observe it, that doesn't mean that there's not something else that's happening.
Well, what I'm saying here, Robert, no one has ever observed a photon. It's too small. No one has ever observed an atom. Right? So do photons exist?
I plead the fifth on that.
All right, let's get back to the hypothesis.
Go ahead.
All right. So you make a set of observations, then hypothesize an explanation which accounts for all the observations. And I got all these links. I'll give them to you afterwards. You can post them. So, okay, let's hypothesize an explanation which accounts for all of our observations. So, with our tree. Since we just observed the tree, how do we account for all the observations? This is your only recourse each and every time you just make an observation of nouns. Your hypothesis from the train wreck observation. In the daytime, open your eyelids, then billions of bits of data hit the retina with which the photoreceptors have to encode and then to the visual vortex to decode. That's symbolic logic. And so voila, a tree. The independent variable here is your eyelids. So that's not a valid scientific hypothesis. It's a train wreck. That's what I'm talking about. You're looking for cause and effect. So it's observe a phenomenon, an action, not just make an observation of nouns. Maybe this will clear things up a little bit. So, construct a hypothesis. A scientific hypothesis is your experiment statement. It expresses the proposed cause and effect relationship. I can't stress that enough. It's a cause and effect question. So the phenomenon that was observed in step one, that's what you're working off. That's your base. So it's a classic if this, then that motif. So the independent variable is the proposed cause that you will test to produce the effect, the dependent variable you observed in step one. See, it makes sense.
Right. Let me ask you this. Right here you're showing it's a classic if this, then that.
Yeah, it's given this situation, then that.
Okay, given this situation, then
Yeah,
that.
yeah.
But what about proving the situation?
Proven what situation?
Again, we're going back to what we spoke about this past weekend about the multiple probability
The
experiment,
probability is
where there can
only,
be many things happening simultaneously at one time, and we're looking at the scientific method and hypothesis is if this then that. What about everything that could be happening?
here, let's go through a couple, examples and we'll get back to that, Robert.
Okay.
All right, so the independent variable is the proposed cause that you will test to produce the effect, the dependent variable, that you observed in step one. So you must have a viable independent variable. You got to have it. So if there's no independent variable, there's no hypothesis. And if there's no hypothesis, there's no science. Okay? Example one, observe a phenomenon. We're going to use the example we used last time. So sailors appear crippled after long sea journeys. There could be a number of possibilities, but for just for brevity, we'll finally realize it's related to diet, like I said. So, construct the hypothesis. If vitamin C intake is crucial to collagen integrity in humans, then eliminating vitamin C intake in humans will cause scurvy. So the if statement is the given, is what you observe. So this is a valid scientific hypothesis, and it's a testable statement. So what are you manipulating? The independent variable, in other words, in this experiment. The answer is vitamin C intake. What are you measuring or predicting? The dependent variable. The answer is scurvy. So the cause independent variable is vitamin C intake. The effect dependent variable, or your prediction, is scurvy. So you conduct the experiment and voila. So if there's no effect, then you try another independent variable. But bear in mind, if you try a variable with no effect, your inquiry or your experiment is not a failure. You've just eliminated a possible cause. So I put another example here. Example 2, observe a phenomenon. So healthy type 1 diabetics suffer from diabetic ketoacidosis, apparently from the absence of the adequate insulin on board. So you want to construct a hypothesis to test it. So given otherwise healthy type 1 diabetes patients, the lack of insulin on board will lead to diabetic ketoacidosis. So your independent variable here, the thing that you're manipulating in this experiment, is insulin, or the lack of. The dependent variable, your prediction, is diabetic ketoacidosis, or DKA. So you run the experiment. And when you run it, you're going to come to the conclusion that insulin deficiency in type 1 diabetes is caused by or causes diabetic ketoacidosis. You understand that one?
Yeah, I mean, I understand that, but there's some people out there who would disagree with this.
I don't know. I don't see how they'll disagree, because this is a hypothesis. There is no disagreement here. This is how you do.
Well, no, there is a disagreement with that, because
Okay.
There are a lot of reasons when you talk about the independent variable, the lack of insulin. The lack of insulin could be some other biological anomaly that could be occurring in one or a larger group of people.
Okay. Okay.
Not,
But look at my hypothesis.
The prediction could vary amongst a group of people, meaning that you can have one group that you won't be able to predict. Your prediction will be invalid, meaning that these people won't end up with diabetic ketoacidosis.
But they do. And look at my statement here. Look at how the hypothesis is written. Given otherwise healthy type 1 diabetes patients, see that one? That's a qualifier.
Yeah.
The lack of insulin will lead to diabetic ketoacidosis, and it does. That's the main culprit.
I can tell you here right now. I went through at an early age of an episode of low insulin level, and I was tested for diabetic
Okay.
ketoacidosis, and that test came up negative.
Right.
And it just so happened that um, there were some other hormonal things happening where literally I had an adrenaline rush that caused me to just physically exhaust myself.
Sure.
And
Sure.
they misdiagnosed it
Sure.
as, you know, having an insulin shortage, testing me for diabetic ketoacidosis.
No, they weren't testing you
No,
for
no, no, listen. No, understand this. They were smelling my breath. They were
sure.
taking my blood.
Sure.
And like, well, do you have a family history of diabetes? And there's maybe one or two members in my family who has a family history of diabetes, but it wasn't passed down to me. So
Right.
that's what I'm getting at with that particular example, is that not everyone who has a lack of insulin will be predicted to have a medical result of diabetic ketoacidosis. It could
Well,
be
well,
it could be
I'm
a
not,
variable of things. There could be, what I'm saying is this: there could be more than one dependent variable. There could be
not,
more than one independent variable.
but
See,
look at
my problem. You and I talked about this weekend, John. My problem with the scientific method, and it's always been my problem with the scientific method, is that the scientific method is just one way of doing things. That's what I pulled up with regard to NASA. They have this one way of testing, of engaging in the scientific method, and
no, they're not engaging in the scientific
no,
method. They're
well,
engaged in
of course
stories.
that's what we're talking about. But
We're engaged right here with the scientific
okay, we're
method.
engaging it. But I want to know if there's a model, if there's a system that tests
Yeah.
all potential variables to the nth, John.
Yeah,
Meaning
I
that,
understand what you're saying here, but listen to your point. Listen to my hypothesis statement. Given otherwise healthy type 1 diabetes patients, they're already diagnosed with type 1 diabetes. So it can't be everyone. It has to be everyone with type 1 diabetes. Now, they tested you because usually in with type 1 diabetes, it usually uh, comes in childhood. And how it's diagnosed, how it presents, is diabetic ketoacidosis because there is no insulin on board. So that's how they diagnose type 1 diabetes.
okay, but if let's just say for argument's sake, we
Okay.
link this back to what we talked about this past weekend, right? And that there's information being transmitted from somewhere for all of us to agree on this independent variable, that type 1 diabetes causes diabetic ketoacidosis.
No, I said the insulin deficiency
Okay,
causes
the
type 1.
insulin deficiency causes type 1 diabetes.
Now, let's say it right. Conclusion: the insulin deficiency in type 1 diabetes
Okay,
causes diabetic ketoacidosis.
now if we go back to what we talked about this past weekend,
Right?
that means that there's a collective agreement of information that came from somewhere. I don't know. You say it came from God or Jesus.
No, 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 no. In this specific case, the experiment shows that empirically, that if you eliminate insulin, then diabetic ketoacidosis results. Now, can it result from other causes? That's what you're saying?
Yeah, that's exactly what I'm saying, because for me, I completely disagree with this. I disagree with it because I look at this as a psychological condition.
No, this is
No,
empirical.
no, no, hold on. I look at it as a psychological condition that manifests itself in a physical manner. A physical manner. Because there are people who literally can think their way out of these type of situations.
Can think they're out of type 1 diabetes.
Well, there are people who've had type 1 diabetes and then All of a sudden now they change their diet, they change a whole bunch of other things, and they don't have this anymore. They don't have type 1 anymore.
No, that's type 2 diabetes. You don't have type 1
Okay, rather
diabetes.
type 1 and type 2, these people just don't have a diabetic chronic condition anymore. Based on the way they change the way they think, they change the way they live, they change the way they eat, they change the way they behave.
That's type
You know,
2 diabetes.
okay, but you're talking about a specific type of diabetes. I'm talking about diabetes in general.
Now, that's why I was specific. Type 1 diabetes. Type 1 and type 2 diabetes are two different animals.
All right, let's go forward
Okay.
with how they go about this scientific experiment, because I'm
Well, the experiment's already done. I mean, uh, this is already a known fact right here. This is it. So let's continue. We'll get back to what you were talking about before.
okay.
So we get to a theory, the colloquial theory. Remember we talked about that's abject speculation. Scientific theories, on the other hand, explain the how. It explains the mechanism or process. You know, for example, germ theory. Scientific theories are the result of validated, confirmed scientific hypotheses that have been rigorously tested. And here's some definitions of it and their sources. A scientific theory represents a hypothesis or group of related hypotheses which has been confirmed through repeated experimental tests. So you can't have an actual scientific theory without it already being validated or confirmed by experiment or hypothesis testing. And you can't have math or equations for a scientific theory. It's tantamount to having a married bachelor. So, can any of these disciplines construct viable formal scientific hypotheses and then propose scientific theories? And this is the list I gave you before. So these blue guys, they can't even get to the first step of the scientific method without a time machine. So they're out. The red guys here, they can get to the first step, observe a phenomenon, but they can't get past that first step. They don't have viable independent variables. So if these guys aren't science, or not, or any of these science, or are they merely juvenile equivocation fallacies? They're the bait and switch motif. So what they say is, we're scientists. We conclude that we poofed into existence from nothing. We live on a spinning ball and evolved from pond scum. And this is science? This is a begging the question fallacy. We're scientists. Please show the scientific method used to validate each claim. They won't be able to. So now we go into the scientific laws. So scientific laws describe. That's all they can do. They describe the what or the is, and they're often expressed mathematically, like the second law of thermodynamics or Newton's first law. So here, the cause or the mechanism, the how or the why, is nonsensical and invalid inquiry. It's just an is. For example, how or why does heat flow from hot to cold always? Well, nobody knows, and we'll never know. All we know every single time, it just does and is. Ergo, a scientific law. Here's a big one. Predictions. And all they are dependent variables. You'll hear ad nauseum, science is, or science says science, and then genuflect, because it can predict, correct? Well, there's a big difference between scientific predictions and your garden variety run-of-the-mill predictions. That is, scientific predictions are the consequent of the antecedent, and that is its necessary condition, independent variables. And here's some definitions and some sources I cited. An independent variable is the presumed cause, whereas the dependent variable is a presumed effect. The independent variable is the core of the experiment. Very important statement right there. It's isolated and manipulated by the researcher. The dependent variable is the measurable outcome or the prediction of this manipulation. It makes sense. It lines up. So predictions without independent variables are the Gene Dixon, Edgar Cayce, Nostradamus, and the Carnival tent predictions. Examples. If the Big Bang is true, then we will observe galaxies moving apart. If evolution is true, then we will observe biodiversity. If the Earth is a spinning ball, then we will observe the Coriolis effect. Here's another one in that same genre. If invisible fire-breathing dragons exist, then we will observe burn or scorch marks on garage walls, right? It's the same thing. What are these? Well, they're textbook fallacies, affirming the consequent formal logical fallacies to be precise. It's a if P then Q, Q therefore P scenario. So the logical fallacy is that P doesn't necessarily follow from Q. So, example, if evolution is true, then you can insert any Darwinian grab bag post hoc observation, fossils, homology, similarity, genetic variation. There's a whole slew of them. So we observe the post hoc observation, therefore evolution is true. So let's construct another one. If I eat a whole pizza, P, I'd feel very full, Q. I feel very full, Q, therefore I've eaten a whole pizza, therefore P. Couldn't I have eaten a 20-ounce ribeye with fries? You have to prove and validate the antecedent first.
So that example you just gave, you ate a whole pizza. So the question is, I would feel very full.
Yep.
Okay.
That's the Q part.
That's a personal observation.
Yeah. This is just an example of the fallacy that's used.
Okay.
Yeah. All right, math. This is a good one. So math isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're different words. Math is immaterial, abstract, often rigidly domain specific, and at best it can only describe. It explains exactly squat, niente. Conversely, actual scientists are in the business of explaining by validating or invalidating cause and effect relationships between independent and dependent variables. That's what science is. Here's a quote from Venkataraman Balakrishnan. Yeah, you can try that for yourself.
Yeah.
That's the whole point about physics. It's not mathematics. So it's not a set of axioms from which you derive results. So I like to use this example right here. According to mathematics, there's an infinite set of numbers between 0 and 1. That is, if I started at 0, I can never reach 1. However, whenever I type an I followed by a B with the same figure on my keyboard on the computer, I invariably pummel this nonsensical buffoonery every single time.
Yeah.
Therefore, there's somewhat of a difference between abstract and physical reality. Can anyone show one case in all of history where mathematics caused any phenomenon? I'd say you had better chances resurrecting Alexander the Great's horse. So physics, physical, concrete. Mathematics is immaterial and abstract. Is there something wrong with this picture? Yeah, you bet there is. Attempting to explain the physical via immaterially and abstractly makes as much sense as suffering from poison ivy on the brain and scratching it by thinking of sandpaper. I'm done. There you go.
Listening to this, what came to mind? It dawned on me. We don't know shit.
Well, what they're telling you is
That's true.
not what it appears to be.
If you have to look at the cause and effect of why something, for the lack of a better word, is what it is, and you can't test it, and you can't get to the genesis root of how it came about, then you can't speak about it.
Well, it depends on your question. It depends on how you frame it and what you're looking for. Because a hypothesis, hypothesis is.
Let's go back to what you're looking for. How do you know what you're looking for if you don't know what it is you're looking for?
Okay, let's go back to the first step. The scientific method. This is why.
Define a phenomenon.
A
Phenomena.
phenomena is an action. It's something that you observe. It's just like what
Okay,
I said with.
but I mean, for everyone out there, I mean, let's break it down. What a phenomenon is. What it is. What does it mean to observe a phenomenon? A
Yeah,
ph- to
yeah.
me, to me, even hearing that word as a kid, a phenomenon is something that can't be explained.
Well, that's why you're going to attempt to explain it.
No, observe. You're saying observe something that you don't know what the hell it is. So
Yeah, that's why you're.
when you use the example of, you know, that's a tree. Is that would you codify that as being a phenomenon?
No, that's a noun.
Okay, so this is a play on words.
No, it's not. It's not. A phenomena is an action that you observe, like you observe crippled sailors walking off the ship, or you observe another phenomenon. Diabetic ketoacidosis is a phenomenon. That's two good examples. That's only the first step of the scientific method.
You broke down when you use the first example of a tree.
Yeah, that's not a hypothesis. I just made that up.
Yeah, you started talking about, okay, what is that tree? How did it get there? How did we come to define that that's a tree?
Oh, that's a different question.
Well, what is that question?
We're not looking. Remember, a scientific hypothesis is cause and effect. We're looking for the cause of the tree. But
Yeah,
you can't speak to it because you're only merely looking at it.
yeah. This all goes back to even when I was a kid, man. People started asking me, well, what is this? What is that? And then I started learning the scientific method, and I've always had problems with it. I still have problems with it to this very day, writing research papers, because here it is, I'm trying to discover or develop a new method of validating or invalidating anything that I say or I observe or I understand. And unless you follow the scientific method, everything else is considered to be moot, invalid. No one wants to even think that there could be another possibility or a variety of possibilities that could exist simultaneously. And that's
Sure.
where the problem is with this. Because John, you and I both, you went through school, you got your degree. I'm going through, again,
Mm-hmm. Mm-hmm.
to earn two different master's degrees, and here it is. I'm keep having to address this entire scientific method. And when you and I spoke about this past weekend, and I let you read that part of that paper I wrote for that professor, what was I trying to do to him? I said
Right.
I would use the scientific method of explanatory research. I'm going to explain to you and propose a new method of research that discusses developing a variety of simultaneous proposals that
Mm-hmm.
could exist in the same environment. And what did the professor says? Well, you're not. And then when I put up the forum post, what did he say? You brought up some good points.
Yeah, that's
I
right.
can bring
That's
up
right.
good points in front of the class, but when I have to put it down in paper and explain it to him, he don't get it
Yeah.
because they want to stick to this one method because, see, it might be complicated for everyone else who's listening, but for you to show this and break this down in these several steps, you could eliminate half of these steps and come to a common sense explanation on why something is what it is without
Yeah, but
going
yeah,
through.
but with the scientific method, it's empirical,
Yeah, but what you explain is that the words using the term scientific method,
right?
science doesn't exist. There's no science involved in this method. There's no science.
Well, this is a logical method right here.
Well, logic.
Yeah, it logically follows. You observe a
There's,
phenomenon, you do a
there's
literature
a shit load
review.
of people out there that wouldn't consider this to be logical at all.
Robot,
I'd like to see why not.
I mean, I want to go to. I want to compare what you just did
Okay.
to what this idiotic NASA is actually saying. So
All right.
let me do this right here real quick. Hold on.
All right.
Let me pull this up. And I'm going to do the share screen to show everyone um, my entire screen. And then we're going to go to the NASA. What is science? And
in the
compared to
sky.
what John just said, and this is what NASA believes the scientific method is: steps. One way. They say it's one way to do science. There ain't no other
No,
way.
no, there's only one scientific method.
No, but I'm just saying. They said there's one way to do science. That's what they're saying.
Yeah, they're wrong.
So they're trying to tell the rest of the world, look, this is how you need to do it. Any other way, no, 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 no. We don't want anyone to know any other way. This is the way.
Officially, they say in scientific usage, a phenomenon is an event that is observable. They say.
It's got to, wait, Mark, so you're saying, Marcus, it's got to be an observable event.
Yeah, it's an
Yeah,
observable phenomenon. Yep.
Okay, but this doesn't, so you're saying this doesn't apply to something that can't be observed.
Like what?
exactly.
So you can't use a scientific method when it comes to quantum science.
Yes, you can.
Really?
Yeah, observe a
Can
phenomenon.
you observe what a quark is doing?
Observe a phenomenon.
Okay,
Robert,
can you
Robert,
observe the phenomenon of a quark and how it behaves?
yeah, I can't observe a phenomenon.
With
What are we observing in quantum mechanics?
How can you observe what a quark does?
Robert, you're asking the wrong question.
No, I'm not. How is that the wrong question? I need to know, how can you observe what a quark does?
The phenomenon is interference versus no interference. That's the phenomenon.
You know, to this very day, since I heard Dr. James Gates talk about there being error correcting code in strings, I still can't find a damn video where he actually shows it. To this very day. And I heard him say that 2 years ago.
No, there's not a video. I think it's a paper.
No, I read the paper.
Right.
But you would expect him to actually present this, to show.
Oh, I see what you're saying, right.
And he's never presented it to anybody. No conference.
Huh.
But no one's disputing what he's saying. No one has ever disputed what this man has said since he wrote his dissertation on the subject.
That's pretty surprising.
So for him to say that there's error correcting code in strings, and this can't be observed, but he said that there's math to prove it, but he's never shown the math to explain how he came up with that theory, and he's a theoretical physicist.
Right.
You see the problem here?
Well, yeah, he's a theoretical physicist. There's the problem.
Okay, so his theories are based on some sort of hypothesis.
It's not a theory. String theory is not a theory.
Okay,
not a scientific theory.
Then what is it?
It's an equivocation fallacy. It's just strings. A string speculations. There's no hypotheses that have been tested.
You know, I'm gonna use his quote. He said, you know what, us physicists, you know, we're just in the business of giving you our best guess.
That's what I'm talking about. There you go. It's speculation. Yep.
Our best guess. Man, listen, the 74 people watching, we can all do that together. Does that make us all theoretical physicists?
Yes, it does, according to them.
Well, then shit, I don't need a PhD then.
No, you don't.
So here's again, this is what NASA's saying. You see something, you wonder what is happening or how it happens, ask a question or make a statement that you can test by an experiment.
That's correct.
The hypothesis.
This is correct.
So the example they give, my kitten plays with the yellow ball more than the dangling black feather. Hypothesis. Okay, hypothesis. Kittens are more attracted to light-colored objects than darker ones. That's a poor hypothesis.
Oh my goodness gracious! And this doesn't surprise me from NASA.
I mean, this coming from NASA. That's a really shitty hypothesis.
Yeah, it's
from NASA. This is what they say science is.
And you wonder what?
Science. Then they say, step 2, define the parts of the experience that would change. These are called variables. For example, the color of the object, yellow or black. Variable 2, the type of the object, ball or feather. Define the parts of your experiment that will not change. These are called controls. For example, the kittens used as test subjects. Control 2, amount of time each test. How does time have anything to do with it?
See, look, they're not identifying what the independent.
Well, I can see where they're saying you're using time with, because they say the cat plays with the yellow ball more than the dangling feather. The cat don't have any concept of fucking time. So how you see where that was just debunked?
Listen, these. It's shocking that they would even. Why would you use kittens and what? What in the world?
But this goes back to what we talked about this past weekend. They're using kittens as an example, and people were supposed to be observing this, right? My kitten plays with the yellow.
Yeah, let's move off the kittens. Go back to quantum mechanics. Go back to the
Okay, let's go back to quantum mechanics. That the test, the control test, a cat doesn't have a fucking concept of time. There you go, right there. There goes. Your test is out the door. It's done. Your cat does not have a concept of time. They don't know if they're playing with one more than the other. Period.
This is preposterous and it, it's not surprising from NASA. That's ridiculous.
So here goes step 3. Find out what people have already said or written about the subject. And this is what we talked about this past weekend, John. Why do I always have to go back to find out, to enhance or further develop somebody's own fucking idea or thought?
Well, listen, they have this step it's out of step. This should be step 2. You do a literature review. And why do you do a literature review? Well, if you're working in a lab,
somebody's already solved this problem.
Exactly.
Yeah, exactly. But what you're also doing is, has anyone else done the experiment to see what colors cat like the most?
Yeah, exactly. So you don't waste your time.
Repeat the experiment or do your own to see if you can get the same result. So what you're doing is what someone else already did, but you're just doing it a different way. You're not doing anything new.
Well, you want to do this before you construct your hypothesis and experiment, because if somebody else did it and repeated it and it's already known, then you're just wasting your time. You're wasting time, resources, and money. And if your supervisor catches you without doing a literature review before you conduct your hypothesis, and it's not there to test the repeatability of it, you're just doing it, he's going to have a little conversation with you.
Okay, but answer me this, okay?
Mm-hmm.
How about in the early 1600s to 1900s, when there was no literature review or research actually conducted, where you could refer back to somebody who actually did the experiment?
Right. It would be hard.
We're using, these guys, these old scientists' information as a standard model of how we should actually be going about our own science today.
Well, what you should do on a literature review is not just the simple superficial look. You go in and look at how they arrived at their results. You go back and look. I had to take a full semester course in how to evaluate research, evaluate research. I'll tell you what, dude, I was dreading that course. It was going to be boring. I'll tell you what, that course was one of the funnest courses I've ever taken. We must have laughed. I mean, I can remember laughing out loud in that course on numerous occasions over these research papers. They were train wrecks, and from the most prestigious journals in the United States, in the world. And I'll tell you what, they were a joke. We were picking them apart. It was like shooting monkeys in a barrel.
Well, you know what I found interesting since I've been, back in school? It dawned on me as I've been conducting all of this literature review of all this science, that when I went searching on the university online library to find the original data that was being referenced from these experiments,
right?
The original data, which should be archived, by the way, which should be archived. Do you know I couldn't find it?
That's not surprising.
Now, and here's what I started thinking. If I can't find the original data in the experiments, the original experiment that was conducted to prove that this law or this theory or this equation or this rule should be accepted as valid, that I could use for the rest of my life, why should I even believe that this is true?
Yeah, we talked about this before. Anchor in
Why
the
should I
fairy
even
tales.
believe that that's even true? Because if I can't find, if I can't locate the genesis of where this information came from, then it's made up.
Yeah, I agree.
And here's the thing, I got challenged. I got challenged to prove that it shouldn't be trusted or believed in. And when I wrote down the textual explanation without doing the math or without doing the science,
Hmm.
the response I got back was, well, then what are you doing here? Maybe you should just, you're done. You know everything. I said, no, I don't know anything, and neither do you. But why do we have to accept? See, that's the point I'm trying to make, is that we're looking at all this data to prove to those people who don't believe what we believe about the earth, the shape, the construct, the design, the function, and you have the majority collective telling us, you lost your mind, you're crazy, you're doing drugs. Really? What drugs? I'm crazy? What makes you think the earth is moving? What makes you think it's spinning? What makes you think you're not standing on a flat surface? Well, the science tells me so. What science?
Well,
Well, why don't you go Google it?
yeah,
I mean, NASA telling me to go Google things.
yeah,
Because they don't know.
That's science to them. That Google and Wiki are science. They're Wiki Google scientists. So, like I said, science isn't a result or an entity. It's a method. So it's silly that they use the term that way. That's the whole problem. They use the term science in so many different ways. It's equivocation fallacy. That's all. It's just a simple fallacy.
Yeah, I want to pull up this document Marcus actually put up in the
Go
group
ahead.
chat. And I want to show everybody. Because it talks about the phenomenon. Hopefully I can pull the damn thing up. So this is a paper. Let me see here. Well, there's a lot of reference sources. Wait, what is this paper, Marcus?
You got it?
Yeah, Gottfried Anger.
I put it in the...
Bro, you gotta let that Jeff Stewart know he's a coward, pussy ass motherfucker, dude.
Dude, what the hell?
I put it in the Mega.
Love you.
Can you see?
What
Dude,
in the
who just
world
came
was
in?
that?
Who just came in?
I have no idea.
Dude, how did Tim Osmond get in here, dude?
I have no idea. Who's Tim
Like,
Osmond?
sending you a link or something?
Who's Tim Osmond?
Dude, he's just somebody that doesn't have enough to do in his life. How did he get in here, dude?
I have
Maybe,
no idea.
I don't know. Maybe you shared the link somewhere.
See, and this is what I'm fucking talking about, dude.
But
This is
doesn't
what-
matter.
Man.
Let them do.
I know who I gave. I only gave 3 people the link. That was you, Marcus,
Yeah.
and John, and one other person. And here we go, dude. You see what I'm talking about?
Yeah, yeah.
And people wonder why I'm a fucking asshole, man. Exactly what the fuck I'm talking about, dude.
What an idiot, yeah. Can you see the mega.nz? There's the file inside, which I sent to you.
Oh, yeah. That was the science, technology, medicine constantly confronted with the necessity to interpret measurements such as interpretation, in particular difficult geophysics. Oh, yeah, I clicked the PDF thing. But Wikipedia defines phenomena are often but not always understood as things that appear or experience for a sentient being, or in principle may be so. In scientific usage, a phenomenon is any event. I just lost my place here. Dude. Hang on a second. Is any event that is observable, however common it might be, even if it requires the use of instrumentation to observe, record, or compile data concerning it. For example, in physics, a phenomenon may be a feature of matter. Okay, I got that. I don't know how this guy actually came in here, dude. That really pissed me off just now.
You got your link. You got the link somehow.
Yeah. Where
Yeah.
you got this link? From
Yeah,
whom?
he got the link somewhere. I think I know who he got it from, and that person is that's going to piss me off. All right, so this is a document that let me look at this document real quick here, Marcus. Let me
You
do a share
download
screen.
from Mega, ne?
Yeah. Let me do a share screen so everybody can see it.
Yeah.
So everybody can see it. Let me pull it up here.
No, there is another one. There's another one.
So what is this document?
This is a different one. This is also about science and how you define science. Yeah.
Oh, how to define science. Is it all in? Okay,
But
most of
there
it.
is the other one. It's called with a mega link. You know, you see the mega link is in the chat. You see the link mega.nz.
Hey, John,
And
this
then,
is what you talked about before, John.
Which
yeah,
one?
To solve an inverse problem from the following points have to be studied. When we talk about inverse problems, the mastery of the special process, both experimentally and theoretically. 2, possibility of mathematical modeling of the process. 3, mastery of the direct problem, both theoretically and numerically. 4, studying of the information content of the inverse problem, i.e. to find out which inner parameters of a system inaccessible to measurement can be determined in a stable and unique manner. 5, development of algorithms for the numeric. Okay, this is
Yeah, that's a lot of theoretical stuff right there.
Here's what they say. Mathematics is the language of physics.
I just didn't I just implode that?
Yeah, exactly. And this is from a paper. When was this paper? This paper was in what year was this paper? I think what latest was published in 1999. It was published actually several different times.
Who is this gentleman?
I don't know. I never heard of him. Gottfried Anger.
Eckhard Friebe is a German
Oh, he's a
one.
retired professor, a mathematician.
Well, there you go.
Wasn't it Tesla who says that, scientists run through equation after equation to solve problems that have no relation to reality?
Yep. That's exactly. He's right on point.
It's in German, Marcus.
No, there's some German and some English.
Yeah, we're gonna do another show for this one. You're gonna have to. You want to present this?
No. There is another one I sent to you.
Okay, let me get to that one. Hang on a second. Let me stop there because I want
to. And set this link.
Okay, hang on. Oh, okay. Let me give you the file. Mega.nz.
Yeah.
So the next thing I want to talk about, Marcus, we're going to have you interpret those 2 videos.
Yeah.
I want to come back to this document, but what I want to do right now, I want to do I want to do a share screen to have you. We're going to play those 2 videos, Marcus.
Yeah.
And then we're going to have you. Who is this in here right now?
Yeah, somebody just popped in here.
Yeah, Tim Osman popped in and then he left.
Who is this? Who is Mag?
It's Magdalene High All. Who is this?
I don't know who this is. I don't know who that is. What the hell is going on, dude? How are these people getting this link?
I don't know.
I mean, come on, dude.
Well, just keep them muted. Just keep any guests muted, and you're good.
Yeah.
And see, yeah, I'm gonna have to be careful, man. All right, so I'm gonna play these videos, Marcus, and then you can break it down for people. I want to let everyone see this. This is on that gasometer in Germany, so everybody can hear this. Here we go.
Das Ziel war, die Schönheit der Erde zu zeigen, dem Besucher die Möglichkeit zu geben, die Erde wie ein Astronaut zu sehen.
Die Erde, die eigentlich eben so zerbrechlich wie großartig, mächtig, kräftig, aber eben auch sensibel ist. Vor ungefähr 2 Jahren hatten wir die Idee, diese Ausstellung zu machen. Und wenn man jetzt reinkommt, sieht man dann diese Skulptur, diese Erdskulptur, die in bewegten Bildern das erste Mal in der Auflösung uns die Erde in dieser Vielfalt zeigt.
Die Erdskulptur ist riesig, mit einem Durchmesser von 20 Metern. Das ist natürlich eine riesige Fläche, die wir bespielen müssen. Die Animation hat eine Auflösung von 58 Millionen Pixel. Das ist riesig, das ist das 7-fache eines konventionellen digitalen Kinos. Und deswegen müssen die Daten auch eine ordentliche Auflösung haben. Von Satelliten bekommt es flächendeckend global. Am deutschen Fernerkundungsdatenzentrum des DLR empfangen wir Satellitendaten, wir verarbeiten diese und archivieren sie in unserem Langzeitdatenarchiv. Es gibt Satelliten, die liefern uns Details im Boden, im Bereich von wenigen Zentimetern. Andere Satelliten, die sehen Wellenlängenbereiche, die für das menschliche Auge nicht sichtbar sind. Dadurch können wir den Wasserdampf in der Atmosphäre sichtbar machen. All das ist in dieser Kugel zu erkennen. Eine wahnsinnig schöne ästhetische Dynamik. Ein ganzes Team hat daran gearbeitet, all diese verschiedenen Datensätze zu einer virtuellen Erde zu kombinieren. Wir haben mit virtuellen Kameras dieses 3D-Modell der Erde abgefilmt und so genau die Animation erzeugt. Das ist unbenötigt.
That's great, dude.
Es ist eine Begegnung von wissenschaftlicher Bildwelt und poetischer Sicht. Man sieht die Feuchtigkeit in der Bewegung, den Tag- und Nachtrhythmus, der uns vertraut ist.
Wir können sehr, sehr schön auf unserer Erdskulptur den Verlauf der Bruchzonen erkennen. Die Stellen, an denen neues Material entsteht.
All das, dieser ganze Reichtum von Geschichten, den wir hier haben, der ist nur auf einem Planeten möglich. Und nun sieht man den Planeten und sieht ihn plötzlich in Bewegung.
Wir arbeiten seit Jahren mit Satellitendaten und sind den Anblick gewohnt. Aber als ich dann für diese riesigen Erdskulptur eben 100 Meter hohen Gasometer stand, da war ich schwer beeindruckt. Das ist ein völlig anderer Eindruck, den man wahrscheinlich so sonst normal bekommt.
You can only play this one, is enough.
Okay. Okay, so I wanted to show that to everyone and let Marcus interpret it.
Yes.
Because what the first thing, when John and I looked at it the other day, the first thing I thought about was that so-called Japanese satellite they claim that is actually looking at the Earth and watching the moon pass in front of it. And that this is everything that they're showing us when they say, okay, this is the Earth, you see it rotating, whatever have you, that they're actually doing it at this facility. This facility has been in existence since 1920.
Let me explain a little bit.
Go ahead.
So the facility itself is an old gasometer. It's in central Germany, and this was used in the steel industry and coal industry in the Ruhrgebiet, you know. When they produced blast furnace gas and coal gas as byproduct of iron production and coking. Okay, so and they used this gas chamber for these purposes. after the Second World War, this was renovated, say like this, yeah. And they put there several exhibitions inside. And the DLR, so the German Aerospace Center, the DLR, in German it's called Deutsches Zentrum für Luft- und Raumfahrt. Eingetragener Verein, so as a foundation. And the DLR is the National Center for Aerospace, Energy and Transportation Research of the Federal Republic of Germany, which is, by the way, not in existence. This is a different story. Its headquarters is in Cologne. You have another great story afterwards with Cologne, but this also the headquarters of the DLR is also in Cologne. And the DLR, they made an exhibition. It's called Wonder of Nature. And this is starting from the 11th March 2016. And there was basically this ball we just saw is 20 meters in diameter. It's a special textile ball. In this complete gasometer, the gasometer is 110 meters in height, which is in 385 feet, I think. Yeah? And the data, they received practically the data from satellites from the German Center of Aerospace, created piece by piece. They have created this. A special layer animation in this textile ball. The great thing is hereby, this is 50 million pixel, which is 7 times more than a digital camera a cinema has. And so that you are able, you can see the steam of the Earth, as well as the day and night rhythm, and the path of the fractured zone of the so-called ball Earth, you know. And the data they receive, and this is the very funny story, because one I have seen is they're using one second, they use the Mercator projection, you know. And the big problem here is that the data they receive, they say that they can use satellites which are very close, can see very close to the Earth on one side, and on the other side they can make visible the data which cannot seen by the human eye, they claim. And all this data which they collected from the German Remote Sensing Data Center, DFD, which is an institute of the German Aerospace Center, DLR, and they achieved this data. Yeah, and the DFD supports science, industry, and public alike. So it provides, with its national and international ground station, have immediate access to the data of the national and international Earth observation satellites ago. They receive the data, they collecting the data, and they archivate the data, and producing this ball Earth, this rotating ball Earth with all this moving stuff inside or outside, yeah, which is absolutely incredible, you know. But this is not real. And now we're coming to the phenomenon. This is how this is working, that the data is coming. So they're creating the data only? This is the question, you know. How they get this data out? From what? From which source they get this data? This is the big question here, yeah?
Yeah.
And they say, one second, and they say that you can practically, you can go with an elevator, you can traveling, this is a panoramic elevator inside this gas chamber, and you can go up to this with this elevator, and you can see the Earth from 36,000 kilometers away on the globe, like an astronaut, they claim. so you can see the Earth, how great the Earth is, and how fragile the Earth is. So they tell us, yeah. And but this is only so basically. This has nothing to do that is used in the 1920s, so only the gas chamber is used from the 1920s. So they make practically, they are an exhibition area, yeah, where they can do several things. Who's inside?
Yeah, it's this is really interesting because there's one video I want to show everyone.
Your husband told me to come down here, man.
Who is this inside?
Yeah, hang on. I want to show everyone this. I want everyone to see this. According to this video, they can project these images outside of this chamber.
Yeah.
Look at the reflection in the river, in the water. Look at the sun in the center. You saw that?
Yeah.
There's a sun in the center.
Yeah.
And they can project all these images.
Yeah. 1 second, Robert.
Yeah.
Can you see this guy here? Who is inside there?
Let me see. This is incredible, man. I don't even know who this is. This is Shroom. How did he get the link? I don't even know this dude, man. See, this is what I'm talking about. This is, I mean, this is ridiculous, man.
I blocked it. I blocked him.
This is just absolutely man. This is what I get when I trust you.
Absolutely.
This is what I get.
But
so, yeah, I mean they're claiming they get those images.
They claim they get this data from the German remote sensing data center, and they are archivating this, and then they producing this visual animation of the ball Earth, you know. You understand?
Yeah.
Why?
Well, this is for exhibition to show the ball Earth, because this is our true reality. We're living on a ball Earth, they say. So we have to show everybody the ball. This is manipulation, indoctrination.
Yeah, that's interesting that you said that you can go inside that facility in the elevator and they allow you to see the Earth, and still there was some
36
satellite.
30, yes.
That
you can see, you can feel like an astronaut.
Exactly. So if they've been, I mean, how long do you think they've been doing this?
Until the end of this year.
This year?
Yes.
So what makes us believe that they weren't able to do it long before that, but they just made it public that they could do it this year?
I think they have not done it before because they built it up in this chamber, but there are several other exhibitions, you know, in this area. So they have to renew it. This was all crap, you know, because when the coal industry broke down, so they had no need for these areas anymore. So they built up this gas chambers and renovated this, yeah. But of course, they can just use it. They can just use it now for the public, and they made it somewhere else. This is, we don't know, yeah, and just showed it now. But this is, for my understanding is how they can collect this data, you know, that they show the ball Earth. Where are the satellites?
Yeah, absolutely.
Problem. Yeah.
So what I want to do now is I want to show everyone. Some people send me an email with this video, and I hate showing this ISS shit all the time. But I want to break this down. I'm not gonna show the whole video. Somebody's got their watch. Let I'm hearing an echo.
Yeah, you got an echo, Robert.
Hmm?
You got an echo.
Yeah, somebody's watching the watch. Somebody's got the watch page. Okay. So this is a video on YouTube called How It Works,
So
the
this is
ISS.
video 2.
Right?
This is a really cool
I'm not going to show much of this.
module. Of course,
Maybe like
modules you see, they have
2 minutes.
and they're put together.
What I want everybody to
sort
pay
of
attention to
work on a flat
is the
plane,
inside of this
either a
this
wall,
module.
a floor, another wall, or the ceiling. But you know, again, all you have to do is turn yourself.
And I want you to notice something.
Changes.
I want you to notice
The
something
reason I'm
interesting.
bringing that up is because this is where 4.
Let me stop this. You see these panels that I'm pointing to?
Yeah.
These panels are detachable. I mean, literally, you could detach this entire panel as one unit, which leads me to the belief that everything attached to this wall is not real. It's not workable.
Yeah.
It's not functional equipment, is what I'm trying to say. All right? I'm trying to tell you that everything in here gets put in here and Velcroed or latched onto the wall, and it's not functional equipment. That's what I'm saying. You don't have to believe that. You don't have to go with that. You don't have to run with it. But when I took a look at this video closer,
And so people always ask about sleeping.
I looked at another video showing
Not really, because it doesn't matter. You don't really have to.
the inside of these modules, and everything looks like it can be taken off the wall very quickly.
Going in right now. Follow me if you want. So I'm inside. It's sort of like a phone booth. It's pretty comfy. I've got a sleeping bag right here.
Yeah, go all the way down in there. Come on. Sure. Okay. Now let me stop this. I'm going to stop this for a second, and then I'm going to take you guys to something that may shock you. Yeah, can you guys on YouTube put your mics on mute, please? Now, this is the European Space Agency astronaut training center. These are full-size mock-ups. Full-size. Okay? Here goes the inside of one of these bad boys. Alright? Go through some other pictures here. As you can see, they got one of the German astronauts standing up inside this with the governor of Governor Handler of Kraft. I don't even know where she's with. I don't really care much. He goes another photo with this astronaut standing here with Angela Merkel, Chancellor. They're standing up in this bad boy. Okay? This is in Cologne, Germany. All right. Here's some pictures here where you show what's attached to the walls. Okay.
My God, Merkel. Wow.
Yeah. Here goes another photo of the inside of the ISS. Now, I want you guys to use your imagination for a bit here. Okay. I want you to look at this. This is stripped down, sanitized. Now, and then ask yourself, if you had all these prefabricated panels, all you need to, you see how this empty space is right here? Think about putting a panel right here with a whole bunch of gear. All right? Look at this here. They covered all this up. Every time we've seen this on the ISS, this is always covered up the same exact way. All right? Now, this is supposed to be a photo of them in space. You see all these wires, all this shit all over the place, meant to confuse you, disorient you, thinking, okay, yeah, they must be in space. Well, I'm getting ready to burst that fucking bubble. Because this website, Astronaut School, this from his website, Wonderslug Doc, here goes this doctor, okay, who is inside that same module, on the ground at the European Space Astronaut Training Center in Cologne, Germany. Now, when you look at this picture, it looks like he's floating or something, right? As you can see that this shit is upside down, appears to be upside down, all right? They say what this facility is. It's the ESA Human Behavior and Performance. ESA Human Behavior and Performance Training Center, okay? It's the European Astronaut Center in Cologne, in Germany. Now, there are going to be people who will look at this and say, well, oh, no, this was just, he just did this, the guy's jumping up or something. No, he's not. Because here goes the photo right here. I downloaded this photo and I flipped it. When they show it on the website, it's like this, upside down. I flipped it right side up. And I looked at this and I thought to myself, okay, is it possible this guy jumped up off the ground inside this module and they caught this picture of him? Is it possible? And then I looked at this and looked at his orientation. I thought to myself, no, it's not. Because the way, if he would have jumped up the way he is right now, he'd have fell flat on his fucking face. The way he is right now. Somehow, they're able to create microgravity on the ground at this training facility. They teach these people how to behave, how to perform inside these modules. They attach the panels to these walls. They do all of this shit. That's my explanation for this. That's my explanation for this. Here goes another picture.
Makes sense.
The rest of these people in this training camp, this center, they're all standing in here. But somehow they're able to create microgravity on the ground. They attach all the panels inside the ISS on the ground, and they create this environment. Yeah, they do their training. And I want to ask you this. I want you guys to look at this real quick here. Because somehow the Europeans train much differently in an aqua tank than the U.S. astronauts train. And the reason why I say that is this. If you look at their suits, how they do their aqua training, they have a lot more freedom of movement. They're not wearing these bulky space suits. Okay? They've got a buoyancy vest on for diving. They don't have no fins. They got regular, diving booties on, regular pants. They can move around freely. This is how they're trained. This is how Tim Peake trained. Okay? But the U.S. astronauts got these bulky suits they're inside of. So my question is, why is it that these guys are not training in these spacesuits in the water like the U.S. is training? And are they going somewhere different? Is this reality? Is this how they're really doing it? Because these guys look like they're in like just regular, normal suits, regular clothes with gloves, and they're doing all their training. Whereas the astronauts from the U.S., they're in full-on spacesuits in the water. Full-on spacesuits. So that's my explanation on how they're faking this. They're doing it on the ground inside that module. They're doing it in here, on the ground, in Cologne, Germany. And I think that's how they've been doing it. It's full size. All they have to do is attach the panels. That's all they got to do. All they have to do is attach the panels from the ISS.
And I sleep upside down. I can't have it. I don't have any sensation in my head that tells me that I'm upside down. So it really doesn't.
So they're creating microgravity on the
The
ground.
sleep station is also like a little office.
I don't know how they're doing it. Maybe they're doing it with a bunch of helium. But here's the thought about that. We all know that helium actually changes your voice, right? But sulfur hexafluoride makes your voice deeper, right? Sulfur hexafluoride. So if you've got a balance of helium and sulfur hexafluoride to keep the voice normal, or you've got some sort of voice modulator device, because the astronauts are supposedly they're speaking with a microphone. So that microphone, I know that the military has actually used voice modulator devices, you know, in specific situations, especially with deep sea diving. Okay, Navy divers actually have voice modulators attached inside their suits because they're breathing pure oxygen. Some of them are breathing other types of gaseous compositions, which changes their voice. I know that I went and did my Navy dive test. You know, my voice changed because we went down to 300, simulated 300 feet. They put in a lot of helium in there, and your voice changes. But eventually, it gets back to normal. What gases they put in there, I don't know. Maybe they put in a little bit of sulfur hexafluoride, but you can breathe sulfur hexafluoride. Not for a very long time, but I'm thinking maybe the microphones, because they got to turn the mic on and off at it, you know, when they pass it on to their mates to talk, that microphone actually may have sulfur hexafluoride in it, and or maybe helium, or it's changing their voice. But they're doing this shit on the ground. They're not doing it up in space. They're doing it on the ground. You saw it for yourself. I'm not saying for sure, but I'm convinced based on what I just showed you, that's what's happening. And the photos that they show from the ISS, we showed you what's going on at the gasometer. There's a potential possibility that's the view that they're showing you every single time. If you go to NASA's YouTube link right now, that's probably what the hell they're showing you, potentially. So if anyone's got any other bright ideas on how they think it possibly may be happening, feel free. Share it with us. Let me know.
It's all about manipulation, Robert. Yeah.
Certainly is.
Yeah.
It certainly is.
And you see it every day. Every day you see this fucking ball. Yeah. In every movie, in every situation. Now the Star Trek situation is coming up. NASA with Star Trek, with the new one. Yeah. They are mixing this together. It's all crap. Yeah.
So I wanna do the whole wave cancellation experiment. If Chris is open to that, I'm actually having some fun with this damn thing, to be honest with you. I'm gonna show. Yeah, go ahead, bro.
Hey, I'm going to send you something in chat. See if you can't pull this and play this at the 10-minute mark.
Okay. I want to show people this. I want to show people this too. This is the radio waves and electromagnetic fields virtual experiment. So I want you guys to see this. This is the electron. All right. This involves radio waves and electromagnetic fields. So if this is your radio station here, 98.7. I'm from New York. That's KISS FM. And here's where the signal is going to. Check this out. When you wiggle this thing, right, low frequency, you see what happens to the other electron, right? But then when you wiggle it even more, you got a strong signal. Look at that. Think about how many cell phone towers and radio towers we have that are generating electromagnetic fields this big. Look at this. Just look at that signal. It's just if you shake it up and down. Let me see the oscillation here. So if I want to do an automatic oscillation, this is what it looks like. If I want to change it to high frequency, to a higher band, look at this. Do you want to know how telecommunications are happening? It sure as hell ain't happening from a satellite. Here it is right here. Let's see if we raise the amplitude. Let's raise the amplitude. You increase the amplitude, here goes your signal transmission. Nothing is coming from space. It's all ground-based. All ground-based. Let's go to full field. Look at the full field, people. Everybody see that? This is the full field. Let's go to half frequency. Okay. Let's go to half amplitude. And there goes your radio wave and electromagnetic field. Nothing. Nothing. It's coming from space. Let's show the electric field. There's your electric field. Right now we're showing the radiated field. Here's your static field. Electron position. I don't need to do that. There you go.
Hey, Robert.
I don't think anybody saw that, did they?
Yeah.
Okay, let me go to this video you just gave me.
Yeah, start at 9:30.
9:30?
Yeah, started at 9:30.
Okay. Let's go to 9:30. Am I sharing? Can people see?
Yeah. Go to 9:30.
Yeah, hang on, something happened here. Okay. Present everything. Come on, what is going on? 9 minutes and 30 seconds.
9:30. Yeah, and let it roll. You'll be stopping it.
Just a slight inconsistency.
Okay. And when you see this, you got to ask yourself, what the hell is shooting that video?
Look at that spin compared to the bottom. Here we have the guy who goes around and when he goes down to the corner, he disappears. Remember that?
Whoa.
Sure, you remember that, don't you? Let's see if we can catch it right where it is. There you go. You start to see through the guy.
Alles manipulating.
Holy hell.
Yeah.
Now you don't have to see it.
Yeah.
Where it was hanging.
You see it?
We saw it in the pictures.
There it is.
And when you turn this video upside down, this one, especially, I made a video from this, yeah? If you turn this upside down, you can see where he's hanging somewhere else, you know? This section.
He's going to hit this little strap down here.
He's hanging somewhere else, you know? This section.
He's going to hit this little strap down here.
He's hanging somewhere else.
What on earth? You back, Robert?
I'm here.
Where's Robert?
What? I don't. He's muted.
Yeah.
But I don't know where.
Jay, I'm
he is.
here. Here's what I'm gonna do, Jay.
Guy go up there with long hair.
I'm gonna show that one video that we said that we were gonna show for everybody.
Goes at a joint 2 or 3 times. Well, her finger. Watch her finger there. Pop.
You're gonna miss the scuba guy.
Not only at a joint, but out of place.
You're gonna
From
miss
the Russians. From the Russians.
Yeah, keep running that video. There's a scuba guy in the visor.
Yeah, hang on, dude.
Okay.
This is fucking bullshit, man.
Yeah, go ahead and play that again. The microphone and the scuba guy.
Yeah.
We already had the invisible guy disappear.
Here we go.
Forward a little bit.
Watch, this is what I'll try to show you. All of them at once get through.
Hey, you're not sharing.
I'm going to pause that. I'm going to go back. You know why? So many people gave me grief over that one picture, or that one video I did. Where
It says I'm presenting to everybody.
I'm not seeing it.
Space for over a year and got fat.
I'm seeing it.
Wait up there while he's trying to grow his own vegetables and have a problem. Powdered foods. And supposedly losing muscle weight as he's up there, even no matter how much exercise you do. This guy comes back 15, 20 pounds heavy. Yeah, And these guys at the International Space Station are thrown against the bulkhead. This is because the plane was coming out of its dip or its great climb, so that they simulate.
Yeah, I think I've seen this before. So here's what I'm going to do, Jay. I'm going to show everybody that one video that you and I talked about that I had did. I don't know if everybody had remembered it, but I'm going to pull it up. What was it? What was the title of the video, Jay? Oh, here it is. What's up, people? John, are you still there?
Yeah, I'm still here. I'm not seeing the screen share though.
Hang on. Okay, hang on. Let me stop it. I'll start it again. Can you see the screen share, John?
Yeah, I got it now. This is my favorite one.
Get this fucking guy. I'm fucking pissed, man. So here it is, people. I want to show you guys this. I want to show you something interesting. Everybody viewing this video, everyone's going to view this video. You can see it's clear as day. There's a fucking astronaut conducting a space funk. Hang on. We forwarded. I don't know. I'm so fucking confused at this point. I don't know fucking space is to be fucking underwater and fucking training center and research center. You know, space. Shut fucking. Oh wait, hang on. This is it right here. Incredible, people. Fucking incredible. Just watch. Absolutely. Wait a minute. We need to go back. Did I just see what I thought I saw? Did the fucking Earth stop moving? Did I see this? Wait. Hold on a second. This is what I want you people to pay attention to. I want to play this again. And I want you to take quick notes. Let's try this shit one more time. I want you to look at this video. And I want you to tell me what you're seeing. The Earth's supposed to be moving. Oh, did you fucking see that? Let's do that again. Let's go back. Here we go. The Earth's not moving. Ooh, you're free. Fly and be free. Holy shit. Let's do that again. So you saw it. The Earth's not moving. Boom. started back up again. Did you see that shit? Oh, fuck that shit. Look.
Be free.
Oh. Anybody want to fucking tell me that's some fucking video glitch? You want to tell me that's a video glitch? You see the astronaut moving, right? The astronaut's movement is seamless, right? So let's see this again. Astronaut's angle, the Earth is moving, right? Are you fucking kidding me? I dare anybody try to fucking debunk this. I dare anyone try to debunk that shit. Two things. They said this mission was canceled. The spacewalk. These two yahoos are outside of the fucking space shuttle. And then we are forced to believe that this shit they're doing is real. Look at the Earth fucking stopped. I need to do that fucking in slow motion, man. Hold on. I need to do that in slow motion. Let me do that again. Let me do that again. Let's change the speed of this bad boy. Let's change the speed. I'm gonna do it to a quarter speed. I'm gonna do it at a quarter speed. And here we go. Quarter speed. There goes the astronaut. The Earth's not moving. They release their hands. Now watch. The Earth's not moving. Is the Hubble attached to the Earth? By some fucking tether?
Unbelievable.
That's classic, dude.
It's the best one I've seen. It's over.
Yeah, it's classic.
That's true.
Thanks for reminding me of that one again. So listen, man, I'm gonna bring this to an end, man, because apparently people can't be trusted, man.
Nope.
Put people.
No.
I sent a guy a link that I thought I had confidence in, and he did nothing but betray me. So he can go fuck off. I ain't gonna say his fucking name. Fuck off. People, it was sporadic. It was all over the place. We apologize. We'll have it better organized last time. Yeah, I figured she would be. I'm not all about these games and shit that they play. They can keep playing them games all they want, but like I said, nobody's untouchable. I got something for them. Don't worry. You guys ain't gotta worry about that. I got something for them. I want to appreciate Marcus. Marcus, thank you very much, man.
Thank you.
We'll probably do another one sometime. John and I will coordinate with you. We want to go over those documents you actually shared. And maybe we can put something together, just the three of us. I will never be inviting anybody else into our hangout. It'll just be me, Marcus, and John. That's it. That's it, man. That's it. People want to go and play games. They want to do that kind of stupid shit. You know, that just shows you right then and there. They can just leave well enough alone. Just can't do it. They can't do their own thing. They got to worry about what else somebody else is doing. I don't play that shit, man. So, guys, I apologize for that. You know, but hope you guys enjoyed this, and we'll see you guys sometime later on. I'm not going to telegraph anything anymore. Whoever shows up, shows up. Whoever doesn't, you know, you'll just watch a recorded show. Again, it's not what you know, it's what you can prove. You guys take good care of each other. Be good. Peace out.